Welcome to part 2 of 7.1 Why Do Living Things Respire? I'll kickstart this lesson with this video on very amazing marathon runner. I'd like you to pay attention to her behavior towards the final line, and then I'll throw you 2 questions to answer after the video.
This is just class right here by both of them. Another fall. We just all want her to just get there. She's given everything she possibly has to get to this finish line.
She is literally, from where we sit, we can see she's less than 50 yards from the finish. Sold, a phenomenal athlete and triathlete, great runner.
She's just willing herself there.
And this is our winner, ladies and gentlemen. This is not normally what you expect to see at the finish of a marathon.
But Chandler Self has run herself to complete exhaustion, and she is so brave. This is incredible. And she's running fast. Remember, she's 30 minutes ahead, or slower than what the time is because she started earlier. She is still going to run the marathon in under 2 hours and 54 minutes. Tremendous, tremendous effort for Chandler Self today.
Oh my goodness. So that's a fantastic time. She's going to be fine. We've seen this before. She's going to be absolutely fine. So don't worry about that. We got to get her refueled and get some glucose and some carbohydrate in.
Alright, so it's really quite impressive to see how marathon runners really push themselves, but I'll put a disclaimer over here. They have been through training, so this is not something that a person without training should do, as it can be quite life-threatening if you really push yourself past the limit. So let's pause over here. The question I have for you is, I would like you to describe one behavior that you observe of the marathon runner on the left, and explain why is she acting or behaving in this manner. So same thing, leave your response in the question. Alright, so you can see that really towards the final end, she's really pushing herself. So where is that energy coming from? In our last lesson, we learned that anaerobic respiration is the one that helps to give the final little additional boost of energy for us to meet the demand of the activities that we are doing. Alright, but you can see that she was in pain. Her muscles were giving way. Her legs were giving way. Towards the end, she really looked very tired and in pain. So what is causing the pain? If you are thinking of lactic acid, you are absolutely right.
This is just class.
Okay, so during vigorous physical activity, alright, and not just vigorous physical activity, alright, short sprint as well. Okay, let's take this down. Short sprint. Alright, you've seen Usain Bolt, very popular sprinters. Alright, they finish running 100 meters in less than 10 seconds. I think the world record is probably close to 10 seconds, or around 10 seconds. So let's ask ourselves, in this 10 seconds, how many numbers of heartbeat and how much air can we take in this 10 seconds? So my next question to you is which type of respiration is supporting short sprints? I'm not going to reveal the answer. Let's continue first, but keep that question in mind. So why is anaerobic respiration so important? It's because sometimes aerobic respiration alone cannot meet the demand of energy required for the activity that we are doing. So in order to increase the energy supply, this is where anaerobic respiration kicks in. Alright, so when exactly does our muscle cell respire anaerobically? When there is a shortage of oxygen. So what happens, right? What happens? Let's just do a little quick recap from what we have covered in the previous lesson. All right, so let's not talk about marathon right now. Let's talk about other vigorous activity. For example, climbing a mountain. Okay, at the start of the climb, all right, your legs feels fine. Your heart feels fine as well. The muscles are using oxygen quite comfortably because you are breathing in, all right, the oxygen, you're taking in oxygen. But as you go higher altitude, as you increase the rigor of the climb, you start panting. All right, you start panting for two reasons over here. One is that your body is trying to remove carbon dioxide. Where does this carbon dioxide come from? All right, it's released during respiration. Okay, and it's a waste product that has to be removed. Okay, so two reasons why your breathing rate increases. One is to remove carbon dioxide, and the second one is to take in more oxygen for aerobic respiration. Okay, to be more specific, but because now we know anaerobic respiration does not require oxygen. All right, so as you breathe in deeper, heart beats faster. All right, but there's a limit. So due to the shortage of oxygen, your muscles carry out anaerobic respiration, okay, for the extra energy, and in the process, lactic acid is produced, incurring oxygen debt. So in this part of the video, I want to focus more on oxygen debt and what exactly it is and how is the oxygen debt being repaid inside your body. So here's a quick summary of the two kinds of respiration that's happening inside your muscles during vigorous activity. All right, so in the presence of oxygen, especially those muscle cells that manage to take in the oxygen, right, they will undergo aerobic respiration to release carbon dioxide and water. All right, and for the muscle cells that are deprived of oxygen, they will then undergo anaerobic respiration to continue releasing energy. All right, but at the same time, lactic acid is being produced. So the total amount of energy from both type of respiration come together to meet the needs of muscular contraction. So why do we feel so tired? All right, at the end of the climb, right, you reach the summit. All right, you're happy, you're contented, but you're still continuing to pant a lot. Right, you think about your 2.4 run at the end, all right, cooling down. Why is it so important to continue walking? All right, to have cool down session. What exactly are you doing to your body during the cool down? All right, let's address it over here today. So the lactic acid that's building up in your body is what causes fatigue and muscular pain. So especially those who don't really do proper cool down or stretches, you realize that you suffer the next day. It's because the lactic acid has not been removed from your body. Hence, there's the delayed onset of the pain that you feel. All right, because you didn't do your necessary cool down and stretches. Right, so the body needs to rest and recover. So what happens when you rest? Okay, what happens when you cool down? All right, pay attention to this. Okay, when you are resting, okay, when you are resting, your body continues to take in oxygen. And what is this oxygen used for? Okay, to continue aerobic respiration. Aerobic respiration will never stop until the day you die. And at the same time, when you are resting, the oxygen is also used to, all right, support the removal of lactic acid. All right, so as you do your laps to cool down, all right, the oxygen that is taken in, all right, will be used to oxidize lactic acid into energy. And where does it happen? Inside your liver. Amazing, huh, your liver? All right, one more role that it plays on top of what we have learned previously is that, all right, it will help to break down lactic acid into energy. Your body is amazing. I always say that, your body always converts harmful substances into useful and harmless, okay, components. All right, so what happens to the energy that is released? It is used to convert the remaining lactic acid into glucose. Why glucose? Right, something very useful to continue supporting aerobic respiration. Okay, and when all the lactic acid is being used up, this is when we can safely say that the oxygen debt is being repaid. So if I were to put it into a word equation form, this is how it looks like. Okay, so lactic acid, all right, it's converted into energy. Okay, like I say, this is really not the best representation over here. All right, but this is just a flow chart. All right, I'll call this a flow chart instead. All right, that the lactic acid is being oxidized into energy, and the energy is used to support, all right, the conversion. Okay, the conversion of remaining lactic acid into glucose. So what happens in your liver? Two things: oxidation of lactic acid to give you energy, and the second one, conversion. Rest assured, I'll be toggling back to the notes in a bit. Okay, so hang in, bear with me first. All right, so this is where I return back to our notes. All right, so I'll pause over here for you to take down some of the key points over here. Okay, so now I'll be using a graph. Okay, graph to pay attention to oxygen consumption, to understand what happens during the start of exercise, during the end of exercise, and during your recovery as well. Okay, so let's bring up my annotation tools right here. So at the start of exercise, okay, we are still comfortably taking in oxygen, okay, at this rate, okay, during rest. So very comfortable. But at the start of the exercise, okay, the oxygen consumption increased drastically. And what is needed is seen in this square over here. All right, this square over here is the amount of oxygen required. Okay, so volume of oxygen required for exercise. But unfortunately, there is a limit to how much it can be taken in, resulting in oxygen depth over here. Okay, so this shaded area is the oxygen depth that we are talking about. So how is this area being repaid? Okay, so it's repaid during recovery. All right, where oxygen is still taken in. All right, oxygen is still taken in. Okay, and as you cool down, your heart rate slows down. Okay, so your breathing rate slows down, your heart rate slows down as oxygen depth is being repaid. So at the end of recovery, okay, your heart rate, breathing, and heart rate returns back to normal. At the end of recovery. So you feel completely alright, you are breathing normally, your heart is beating at a normal rate because oxygen that is being repaid when lactic acid is removed, completely removed. So this amount of oxygen taken in after recovery is used to remove lactic acid. So I hope you can understand my annotation and what this graph is trying to tell you about oxygen consumption at various time points. Alright, so this is a quick summary. You can press the pause button over here to take down and fill in the blank of your notes to understand how oxygen debt is being repaid. Alright, and what exactly happened to the lactic acid that is being transported to the liver to be oxidized into energy. And the energy that's released is used to convert remaining lactic acid into glucose to be used for other cell activities. And when oxygen debt is successfully repaid when all lactic acid has been removed. So if you have done your cooling down properly, your stretches, you will not wake up with any pain in your muscles the next day. Alright, so how is oxygen debt being overcome after exercise? Alright, your body undergoes the following. Okay, immediately at the end of a marathon run, a 2.4 run, or the mountain climb, your heart will continue beating very fast. Why? It's to transport lactic acid from muscles to liver for it to be broken down, and then for your heart to continue pumping oxygen from the lung to the liver. Alright, where the breakdown of lactic acid happens. Okay. Alright, and in order to supply the oxygen needed, you continue to breathe in very deeply and very fast even after you're done with the exercise. So the immediate effect after you stop the exercise, you continue to breathe hard, to breathe fast, and your heart rate continues to beat very fast. Okay, so this was the question that I left you at the start of the video of this lesson. Alright, so as compared to marathon, I want you to pen down, how do muscles obtain energy during a short sprint? Imagine a short 100-meter sprint, for example. Alright, so that marks the end of our lesson on 7.1, how living thing Respire. To conclude, let's summarize using the slides that I have. I will be uploading this deck of slides as well for your reference. Okay, I'm not going to bore you with the details that I've gone through. Okay, and go straight to the summary over here. Alright, so let's summarize before we try out the checkpoint question. So energy is required for life processes. There are so many different cell activities and also body activities that requires energy, and they are all stored. Where can we find this energy, right? Chemical potential energy that's stored inside the food molecules. So how do we extract the energy? We got to break it down through respiration, alright, to break down glucose in order to release the energy that it contains. So two types of respiration. Aerobic respiration occurs in the presence of oxygen to release a large amount of energy, while anaerobic respiration occurs in the absence of oxygen, which release a small amount of energy. Alright, so I'll leave you with the checkpoint questions to answer on your own. Alright, two very quick questions to evaluate your understanding of this entire chapter. Alright, and I will not be releasing the answer. Alright, I would like you to try it on your own, and then we do a quick recap when we are back in school. So finish out this entire page on the checkpoint questions, and then I'll follow with the next segment on the different structure and function of respiratory system. That's all.